Hey Chargers, today we're going to be looking at our special cases that we have for when we solve our equations. There are two other situations that could come up while we're working on solving, so that's what we're going to look at. Now, we're going to go through and solve the exact same way we've been doing the last couple days. We're going to follow all the same steps that we have been looking at, and those are at the top of your notes page. It's the exact same thing. So the first thing I'm going to do is draw my line where my equal sign is. I'm going to look for anything I can distribute. So on my left side, I can distribute this -2 into my parentheses. So -2 times 3r is going to give us a -6r. -2 times -1 is going to give us a +2. Negative times negative gives us positive. On the right side, we can distribute, oops, sorry about that. On the right side, we can distribute as well. We have that negative sign in front. So remember, you can draw in that 1. That's the same thing as saying -1 times 6r and -1 times -2. So when we do our -1 times 6r, that becomes -6r. -1 times -2 is going to be a +2. Now I have nothing on the left side that's a like term that I can combine. I have nothing on the other side that's like terms that can be combined. So now I'm going to get rid of my variable on one side. I'm going to go ahead and get rid of this 6r, this -6r that's on the left side of the equation. So -6r, the inverse operation, the opposite of subtraction is addition. So I'm going to add 6r to both sides. When I add 6r to both sides, on the left side here, -6r plus 6r, that gives us 0. So 0 plus 2 is 2. On the right side of my equation, the same thing happens. -6r plus 6r is 0. So I have 0 plus 2 over here also. And I don't have any more variables in my equation. They have all canceled out. They're all gone. So that's what happens. That's one of our special cases. In the process of working through all of our steps, we lost all of the variables. Now, 2 does equal 2. That is a true statement. So since everything for my variables canceled out, since I have no more variables as I'm working through this, but I have a true statement, that means that any number I plug in for r is going to work. If I plug in a 3 up here for my r on both sides, I'll get a true statement. The left side will be equal to the right side. If I plug in 152 for r, the left side will be equal to the right side. Any number I pick, and since we have an infinite number of numbers, counting never stops, that means that we have infinite solutions for this one. So that will be your answer. Your answer when this happens will be infinite solutions. Now, if we scroll down to number 4 here, this is going to be a different special case that we have. This is the second one. But same thing. I'm going to follow all the same steps. I'm going to draw my line. I'm going to look for anything that I can distribute, and that happens on the left side here. I have 3 that can be distributed into that parentheses. So 3 times y is 3y. 3 times -7 is -21. On the right side, there's nothing to distribute, so I'm just going to bring that entire side down so I can keep my equation going. Now, since there are no like terms on the left side or the right side that can be combined, I'm going to work on getting rid of my variable on one of the sides. I want all my variables to be all together on one side of the equation. So I'm going to look at this left side here, and I'm going to go ahead and get rid of this 3y. So since it's a positive 3y, I'm going to subtract it. And then I have to do the same thing on the right side as well. And when I do that, 3y minus 3y on the left gives me 0. So 0 minus 21 is -21. And on the right side, 3y minus 3y is also 0. So now we have 27 plus 0, which is 27. Now the same thing has happened as far as all of our variables have gone in the process of working through all of our correct steps. We have no more variables left in our equation. But this is a little bit different situation because negative 21 is not equal to 27. That is not true. When you have all of your variables go away in the process of going through your steps, and you end up with a statement that's false, like this one, that means there is absolutely nothing that we could plug in for y up in the original equation and get a true statement from that original equation. There are no numbers that will work. So that means that there are absolutely no solutions that will work for this equation. So that will be our answer. So if you lose all of your variables and you get a true statement, like in number 2, then you have infinite solutions. If you lose all your variables and you get a false statement, like in number 4, that would be no solution. And those are your 2 special cases.